Hello everyone. Today our topic is how to remove duplicate records based on primary keys using row underscore number function using PySpark. So the content of this video is how to remove duplicate customer records and how to filter duplicate records based on multiple primary keys and how to use row underscore number in PySpark SQL. So these topics we are going to cover in this video. And before that, first we'll understand what is row underscore number. So it is one of the window function. So that assigns a unique and sequential integer number to each row within the window partition. So that starting from 1. So that means suppose if you have uh, input like this, and if you apply partition by on this customer ID, so then what it will do, it will divide into groups. So if you consider this is first group, so you can say that is first group or first window. So within this window, it will assign the ranking based on by using row underscore number function. So like 1, 2, 3. So that is the meaning of this one. Each window partition, it will assign the unique and sequential number. So unique and sequential means it will start from 1 and 1, 2, 3, 4 like that. It will go sequentially. Even if you have duplicate records, it will go sequential. So it will not do like if you have duplicate records, it won't give you same number. So it always give sequential number, sequential and unique number. So it is commonly used for tasks such as ranking to identify top or bottom records, or simply adding a unique identifier to rows based on a specific order. So specific order means based on ascending or descending order. So first we'll see with some scenario. So before that, I'm importing the required functions. So mainly window I'm importing. To perform any type of window function, first we need to import this window from PySpark.sql.window, import window. And since this video restricted to row underscore number function, so I'm importing here from SQL.functions. So our scenario is how to remove duplicate customer records. So if you see the scenario, like if you're working as a data engineer in a marketing company, so customer data is coming from multiple source systems. And due to retries and reprocessing, duplicate records are created. And requirement is keep only the latest record per customer based on load date. And second one is remove older duplicate records. So first we need to understand this scenario, what it means clearly. Like, so our source data, it is coming from multiple source systems. And due to retries and reprocessing, duplicate records are generated. So generally in real-time projects, we'll follow Medallion architecture. So from source system, first we'll move data to storage account. From storage account, we'll move to different layers like bronze, silver, gold. So whenever you do extract data from source to uh, storage account, then storage account to bronze. So during that time, if you by in case assume that your pipeline is scheduled on daily basis, it is scheduled. So somehow one particular day it ran 2 times. It ran 2 times or multiple times. Or by consider this scenario, like you created one airflow pipeline, means the airflow DAG is created. ADF pipeline is created, ingestion pipeline is created in ADF, and that is you are triggering through airflow pipeline by using DAG. Somehow your DAG, it is running twice per day. So generally it is supposed to run as per your schedule every day morning at 11 o'clock. But somehow due to some reasons, due to your deployment error or bug at airflow, the pipeline running twice. So what will happen due to these multiple times running the pipeline, your data loading to bronze layer multiple times. So that means, so whenever you pulling data from bronze to silver, these two loads, that means as per planning, 10 o'clock it is running, and you assume that again 11 o'clock it is running. So these two data accumulated in bronze layer. So generally, if ingestion pipeline starting at 10 o'clock, and usually they'll give some gap, at least 1 hour or 2 hours, they'll keep time difference to start transformation pipeline. But within this time, by mistake or somehow, your ingestion pipeline ran 2 times. So that means two loads of data, it is accumulated in bronze layer. So when transformation pipeline starts, what will happen? This particular day, this two loads of data, it will directly move to silver layer. So that time, while moving that, your pipeline will get fail. Why? Because it will mention that due to merge conflict. So merge conflict means because of multiple source data at source level, so it not able to decide which one to merge or replace. So this is the common error everyone face at real time. So that is the meaning of due to retries and reprocessing, duplicate records will accumulate in bronze layer. So whenever moving from bronze to silver, so your pipeline will get fail if you don't uh, created code to remove the duplicates. Okay, so how we can avoid this? So for this, we had to write the window function by using row underscore number function. First, we need to filter out the duplicate records. And one more thing we need to understand here is requirement is keep only the latest record per customer based on load date. So assume that bronze to silver, everyday pipeline runs. And whenever pipeline runs from bronze to silver, so once the data is moved from bronze to silver, so one load date column will be added. This we can call as metadata column. Why we will add this column is based on this load date, we can come to know that one particular day, how many records are generated. And if you have multiple times a pipeline run, then also you can identify. Because whenever first time pipeline ran, so suppose some 100 records it is moved to bronze layer. So this timestamp will be almost similar. Some minutes or 1 or 2, 3 minutes, it will be difference. So whenever it runs second time, maybe half an hour or 1 hour, so it will be easy to identify uh, based on this load date. So here what they're telling, keep only the latest records per customer. Suppose this is the records, it moved from bronze to silver. So while moving that bronze layer, you find that there is some duplicate records. So you assume that, so here, this is the duplicate record, these two. So we need to decide which one we need to drop the duplicate record, whether this is latest record or older record. So here, this particular case, I given load date, only date I given, but sometimes it'll be timestamp also. So date and time also. So this is a new record. From these two duplicate records, this is the latest record and this is the old record. So we need to decide which one to which one to drop, whether latest record or old record. So that is the meaning. Keep only the latest record per customer. So that means since they mentioned we want to keep only latest record. So what is latest record? This we want to retain, and this we want to drop. So that we need to define in code. So that we'll see how to define that. So next, remove older duplicate records. So that means retain latest record and remove older duplicate record. So that is the requirement. So this is the scenario now. So this is sample input data. This group is and 2, 3. So if you see here we have one duplicate record and 118. So this is latest record. This is older record. So this one we want to drop. And similar way here we have 3 duplicate records. So in this 122. So this is latest record and these two are older records. So these two we want to drop. And after dropping, you see from each group, one record will be there. So 101, one record. So 115. If you see here from these two records, 115 is the latest that it printing here. And at the same time, 102, we have only one. So we are getting same. Next 103, we have two records. In that latest is 118. So 103, we are getting 118. And 104, we have 3. In that latest is 122. So 104, 15, 15. Okay, so this we'll see. So latest record 2000, it should be 122 since it is 22. So we'll see this, whether any typo or something. So 105, since we have only one record, we'll get this one. So this is our scenario and this is our sample input and output. So now what I'm doing, so with the same sample data, I created data frame by using spark.create data frame. So this is my sample data frame. And on top of this, what I'm doing here, I'm using window function. So here what I'm doing here is first I'm defining WindowSpec. So one variable I'm defining. In this variable, first I will define partition by and order by. So later this variable I will insert in over condition. So I already imported this window function. So window.partitionBy. So partition by what? Customer ID. So always remember that whatever we pass the column names inside partition by, those are all the primary keys in your real-time projects. So in this particular case, I have single primary key. So that's why I passed only single column, that is customer ID. And so this partition by is over. So partition by customer ID means it will divide it into groups. This is one group, this is one group, and these two. Sorry, these two one group, and these three one group, and this one group. So after doing group by, what need to do is order by. So we'll use normally order by, and inside order by we'll pass column on which, based on which column we want to do order by. So this is important here. Whenever removing the duplicates in real time, always we mention order by column as date column, either date or timestamp column. So here my metadata column is this one, load date. So this load date, it is not coming from either source or something. So we are creating these metadata columns for our purpose. So here partition by, inside order by, we are passing column. So that is load date, order by load date. So why we're passing this load date? Because we want to filter the records based on load date. See here, keep only the latest records per customer based on load date. Okay, so that is the reason we mentioned order by call load date. And why we are defining descend descending order is, since we want latest record, if you see from this window, they want to retain only latest record. That means this one. So if you mention descending on this load date column, what will it will happen? It will come in this order, lower to higher, so that it will pick the uh, latest value. Suppose if you don't mention this descending, by default PySpark considers ascending order. So what will happen? It will pick this value. Instead of this one, instead of latest value, it will pick older value. So that I will show you how it works. So after running this, here what I will do before running this, I will remove this descending here. First we'll see without descending how results comes. Then we'll see with descending. So this is ascending. Now what I'll do, I'll try to run this one. Okay. So here what happening? Since I given order by call load date in ascending order, then this whole window spec I'm passing inside over. So here I'm adding one column, that is rank column. Since I dropped here, it not showing here. What I'll do, I will uncomment this one and I'll show you this one. And before that, I will uncomment this also and I will show you without filter how it comes. Okay, so here what I'm doing, I'm using with column method and I'm adding one column, that is row underscore number. And here I'm using row underscore number window function and dot over, and inside that I'm passing this partition by and order by. And if you see here, so this is our original data frame up to here, up to load date. So since I given order by on load date, and by default it will consider ascending order. So what will happen? So for first window, you see here 1, 10 and 1, 15. So rank is given 1, 2. So next here 2 is single only, and 3 we have 2. So 11, 18, 1, 2. So next 104 we have 4 rows, that is 5, 15, 22. So 1, 2, 3. So now what will happen after after defining this rank? What I'm doing? I'm doing filter. What I'm doing filter? Filter is equal to 1. So that means it will retain the records only related to 1. So remaining things it will remove. So finally, what will get? Only older records will get. Older load date rows will get. But this is the latest record. But how we'll get this latest record? So for that, so here what I will do, this is let it be. So here I will show you. So here what I did, I try to comment out first these two lines. Later I will do uncomment. So here what will happen, since I added descending order. So now see the ranking, how it comes. See here, since I mentioned descending, so first coming higher value, next it coming lower value. But in case of here, first it is coming 10, then 15. So ascending order. So here what it coming? It coming in descending order, 15 to 10. So according to that ranking is giving. So now if I do filter with equal to 1, that means only rank ones. What I will get? I will get records related to rank 1. So that means this one, latest record. So that is the difference between without defining descending and ascending. And this how we can get the latest records by using descending like this. So now if I uncomment this one, filter, so what will happen? It will filter only rank ones. So wherever rank is there, rank one is there, it will filter only those records. So here we'll get only ranks one. So those are all the latest load date rows. Then there is some network issue. Okay, so let it run. So what will happen? Filter is it you will get only rank one things. So later what I will do if I comment it out to this one drop, then what will happen? This row also will remove. So finally we'll get only these columns with only values of rank one. So once okay, so now you got it right, only rank one. So now what I will do, I will again uncomment this one drop. So now this column will go and you will get only the latest load date records. Now here 122, right? So and if you see at the starting, I think this is wrong. 122, where it comes 122, that is related to 104. 104, 122. Okay. So now we'll jump onto other scenario. How to filter duplicate records based on multiple primary keys. If you see in real time, very rare cases will get the tables with only single primary key. So we always will be having multiple primary keys, or you can say composite primary keys. So for this, I'm creating a data frame by using SQL here. So this is my table, sales underscore events, and these are all my columns. And these are all the data I'm passing here. And here, instead of date, I'm taking timestamp. Instead of date, I'm taking timestamp here. And you can see, so this particular day, this many records got added. So date is same, but if you see time difference is there. This is at 10 o'clock, 10:05, 10:45. Okay, so and here for identification, I mentioned which are all the duplicate records also here. Okay, so this is my sample data frame. On top of that, what I'm doing, since I created table by using SQL to perform PySpark operations, what we need to do, we have to use spark.sql. So spark.sql, and inside that we need to pass the SQL commands like select star from sales underscore events. So sales underscore event means this table name. So if you call this one and display, and this one I define to one variable. So now our data frame is stored here. Okay, so this is one of my data frame, and you can see the timestamp here. And one more method is by using Spark method, PySpark method. So same data I'm passing here, duplicates everything, data is same. So columns I'm defining here, and by using Spark.create data frame, I'm creating the data frame. Since we are creating manually here, by default, this timestamp column will be with string timestamp. That means the string type will be their data type. So that one I'm converting to timestamp by using cast method. So for that, I'm using with column method, with column event timestamp. That means this one, this column, existing column, I am overwriting. So that is call of event type by using cast method dot cast to timestamp. So what will happen? So you will get timestamp. Data type is a timestamp. Suppose if you don't do this one, maybe suppose I will comment it out this one, then we'll see the data type. So if you see the data type, so string it is coming. So that means this is string timestamp. See here, this is string and these are all the timestamp values. And if you observe here, this is a date and this is a time. So in between, we don't have anything. We don't have T or we don't have milliseconds. So after I convert this one to timestamp data type and observe the change. First data type will change. It will update from string to timestamp. Again reconnecting. Okay, first it will convert from string to timestamp. And here also you can see the change, like the string will change to timestamp and these values also will get changed. Like in between T you will get, see here, in between T you will get, and it will, my seconds also will get. So earlier we have only hour, minute, second. Now it will get add milliseconds and time zone also after converting to timestamp. At the same time, you can see here it changed from string to timestamp. So now I am defining my primary keys here. So since we are looking into multiple composite primary keys, so primary keys I am defining here. So in between by using delimiter pipe, delimiter as pipe. So sales ID, event ID, task ID, purchase ID, custom ID. So this many is my primary keys. So first I'm printing primary keys. So these are all my primary keys. So, but for PySpark, since we want to pass as a list of elements, so this I'm converting these primary keys, this string I'm converting to list by using split method. Primary keys dot split, and what is the delimiter here is pipe. Pipeline is the delimiter. So if I do split, it will convert from string to list. So here what I can do, I can print a data type also. So type of primary keys and the same here also. So first this input primary key means data type, it will give you a string, and after converting it will give you list. I think some network connection, it multiple times reconnecting. So parallelly, we'll see this code before running that. So here what I'm doing, I'm applying same method. So partition by, so window.partitionBy. So earlier we have since single column, so we directly passed. So since here I have multiple columns, what I'm doing here is, okay, so here since I have multiple primary keys, what I'm doing, so I'm passing this list of columns. So this list of columns I'm passing here. So how I'm passing that variable I'm passing here by mentioning star. So whenever you're passing list of elements here, any of the function, we need to mention * here. So * that variable name. So now this is completed, partition by the list of columns, and next order by, this is my column, event timestamp, and I'm giving dot descending. So we already discussed why we need to give descending here. So here row number is imported here. So first I defined my variable here with partition by and order by. And this variable I'm passing inside over. So what exactly I'm doing here is on top of our sample data frame, I'm trying to add one rank column. So that is this one, row underscore number. So for that I'm using with column method. So with column, and this is my column name, row underscore number. And here we are using row underscore number function. So row underscore number function dot over, and inside over we are passing this one, partition by, order by, these things in descending order. So now what will happen? So since our primary keys we mentioned, uh, as all these columns, all ID columns. So all ID columns up to here. So in this, what are the common records? So S1. So this one will become one group, and the S2 is single, S3 is single, S4 is single, S5 is one group. These three one group, and S6, this is one group. Okay, so now first we'll look into S1. So this group will see. So based on primary keys, so that means based on this many columns. So this is one group. So now in this group, since I given order by on event timestamp, and it is in descending order. So descending order means first highest timestamp value will be there. So 10, 45, 45 is the highest value, that getting 1. So next is 5, that is rank 2. So next is 0, that is rank 3. Suppose if you remove this descending, what will happen? It will come in reverse order. So this will come here. So this will be rank 1, this will be rank 2, this will be rank 3. Okay, so since we want latest records, so I used descending. So next, this is we have single record. So 1 we are getting, and up to here it will be one single record. So 1 we are getting, and here these three is the one group. So in this, if you see, is because of descending, we are getting highest timestamp. So 20, 35, 40. So that is rank 1. Next 19, 55, 10. That is rank 2. Next 18, 35, 10. So that is rank 3. And the next one is single row, that will get rank 1. So now what I'm doing after applying window function, I'm doing filter. So on top of this data frame, I'm using filter, and on which basis I'm doing filter? Inside filter, I'm mentioning sample data frame is this one. So sample data frame is one, ranked data DF. That is this data frame. Dot row underscore number means this column. So this in this column, it will do filter which are all rank greater than 1. So that means except 1, whatever it is there, 2, 3, all these things will get a drop. So finally, here we'll get only the rows which has uh, ranks greater than 1. Okay, so this is to highlight the duplicate records. So next, what I'm doing, same filter method, instead of greater than 1, I'm passing is equal to 1. So is equal to 1 means first it will pick only the records uh, is equal to 1. That means rank equal to 1. So after filtering, what I'm telling to drop the row number. That is this, whatever new column created, that I'm asking to drop that column. So what we'll get finally we'll get original data frame with all latest records. That means with the latest timestamp. And if you see from each group, the highest timestamp it will print here. So this is the final data frame after filtering duplicate records with the latest timestamp. So next one is same thing how we can do in PySpark SQL. So PySpark SQL, how we can do is, so if you create any data frame, means suppose I created one sample data frame by using PySpark. Suppose this is my initial data frame, that is df df underscore multiple key. So this is PySpark data frame. But if I want to work in PySpark SQL, what we need to do, first we need to create one temporary view. So how we can create the temporary view is, this is our sample data frame. On top of that, I'm using create or replace temp view. So this is the function to create the temporary view. So this is meaning is temporary view, and this is create or replace. So this is same like creating the table. Suppose in case if you mention create temp view, what will happen? In first time it will run successful. In second time if you run, it will throw error like table is already existed. So for that is the reason we are using or replace. So same thing we'll do while creating the table in SQL. So create or replace table like that will do. So same function here. So my temporary table name is this one. So now this is my table name. So here what I'm doing, Spark.SQL. So if you want to write any code in a Spark SQL, PySpark SQL, so first we need to write Spark.SQL, and inside that we need to start and ending with triple quote. So in triple quote, we had to write same SQL code. So whoever comes from SQL background and whoever knows SQL, so same we can write here. So select star, row underscore number, over partition by. So these are all my multiple primary keys, and order by this event timestamp in descending order. And this whole thing I'm mentioning, my column name as row number. That is this one row number, and from source table. What is this source table? From this temporary table. Okay, so based on this, it giving you ranking. So in PySpark, how it giving? Same way. Since I given descending order, here you are getting highest value as first. And this up to here it is fine. So here, this here we are getting highest value, higher to lower. And after that, after generating the rank, how to filter. So same code, here what I'm doing, I'm adding only this where condition. So where row number equal to 1. So what will happen? It will display only the records where rank equal to 1. Rank equal to 1. Okay, so this is the scenario how to remove duplicate rows from your data frame by using primary key, that is single key, and multiple key. So this is the way we follow in real time. And if you come here, so you can see the data type. So initially this is string. And if you see the data type, so here we are getting initially string. And after applying split, it converting to list. Okay, so this is about defining multiple primary keys. So these primary keys, so finally, what is the primary key? This one, after splitting LST P keys that we are passing here, primary keys. Or what we can do is, instead of doing this split everything, so all these keys, that means this list of keys directly you can pass here. You can directly pass here, or you can define one variable here. Here we can define one variable like LSTP keys equal to this list of elements. So that also fine. So both methods are fine. So finally, we saw about how to drop the duplicates based on primary keys, both single primary key and multiple primary keys. So that's all about this video. If you really like this video, please like and subscribe. Thank you.